Okay, good morning, everybody, and welcome to the All Egg Hot Stove here on March 5th. We're excited to have everybody here. For those that don't know me, my name is Katie Magison. I'm a sales agronomist here with Beres Seeds, and I am excited to be chairing this meeting this morning. If you haven't attended an All Egg Hot Stove in the past, we skipped doing them last year, and the purpose of them really is to just bring together some experts from the ag industry to share information that will be valuable to you and your farm or the farms that you work with. So for anybody that doesn't understand what a hot stove topic is, it was originally years ago just a forum for deep analysis and knowledge sharing amongst colleagues, and it was typically done around a fire or a hot stove. So that's kind of what this is, and we encourage you to participate with questions. If you do have any questions, please send them in the chat function of the meeting, and we're going to save the question period for both presentations until the very end of the meeting. This is a recorded meeting, and with the exception of Sherilyn's presentation, we will be sharing it on our YouTube channel. So you're getting kind of an exclusive session with Sherilyn here for those that are joining online today. So we wanted to say thank you to our sponsors for this event today, Nexus Bioegg and North Star Genetics. We do really appreciate your support for bringing this meeting together for our customers and colleagues. We're also going to have a draw to win for all the attendees today. We didn't promote this, but this is something we'll be doing. You can only win this wireless meat thermometer if you are stay tuned until the very end. And we will throw in an extra entry for those that ask questions, so you'll get your name in there twice. So stay tuned for that. And one more thing to plug before we get going here. In mid-February, we announced that Beres Seeds is hosting a polar plunge in support of STARS Air Ambulance. As of Sunday this week, we reached our fundraising goal of $30,000. We are so grateful to everyone who has donated and for those who are participating in the polar plunge and helping with the fundraising. And we want to keep this momentum going in support of this organization that is so important to rural communities and families. So we will be increasing our goal. We have 3 weeks left to reach a new goal. So if you would like to donate, please take some time to scan the QR code on the screen, or you can find it in a link in lots of our social media posts on Twitter and Facebook as well. So thank you again for all of those who have supported. Okay, just admitting some final participants in the waiting room there. And we will get going with introducing our two presenters for the day. First up, we have Dr. Brian Beres, who is a senior research scientist at AAFC Lethbridge and is additionally a professor at the University of Alberta. Dr. Beres leads several multidisciplinary projects developing the G/E/M crop management systems. His impact on academia and industry has been recognized on several occasions, including the Alberta Seed Growers Honorary Life Award, the Canadian Journal of Plant Science Best Paper, CJPS Outstanding Associate Editor, and fellow Canadian Society of Agronomy. Dr. Beres published in the areas of agronomy and crop science and has been the author or co-author of 116 peer-reviewed research articles, 2 edited books, and 2 book chapters. He serves as the editor-in-chief for the Canadian Journal of Plant Science and special issues editor for Frontiers in Plant Science. Dr. Beres has several international collaborations and represents Canada on the research committee of the Wheat Initiative, where he also developed and chairs an expert working group for global agronomy wheat research. With that, please welcome Dr. Brian Beres, and I will stop screen sharing.
Thanks, Katie. I think we've got one person that's not muted calling in. Be good if they muted, because I'm going to have enough technical difficulties myself, I'm sure. So
I just hit mute all on everybody. Sorry, Brian, so you'll have to unmute.
Okay. Can you see and hear?
Yes, all good.
Okay. Well, thanks, Katie, for the invite, and good morning, everybody, from Lethbridge, Alberta. So thanks to Katie for robbing me of some beauty sleep here. But at least this time of the year, even if it is -22, it's still nice and bright and sunny, even at 6:30 in the morning. So that's been nice. I'm going to talk to you a little bit about a project we started, or that I conceptualized, I guess now it's been over a decade ago. And first person I want to really highlight here is Graham Collier, the second author, who was my PhD student and now is Dr. Collier. And he kind of grabbed hold of this concept and took it and ran with it and conceptualized some other studies to add on as far as a best management practice goes. We needed some, at least I thought we needed some germplasm support. So that's where Rob Graff came in, providing us with that. Dean Spanner was the co-supervisor of Graham up there. And then we've got some collaborating agronomists, Quilu out of Swift Current, Bill May, Indian Head, Chris Willenberg out of Saskatoon. And then we're now working on Durham. So we got Curtis Posniak out of CDC, Saskatoon, and Ruan Yufang out of Swift Current, helping in that regard. So what I thought I'd talk about quickly today is just give you kind of a background to the topic, what kind of got me thinking about it and how that relates to prairie climate trends, and just some conventional thinking about there's been some rethink by some global physiologists on how we should be approaching wheat anyway. And so I'm going to talk a bit about that as well, and then the whole concept. And where we're at with ultra early seeding. So there was a nice review paper just this past year in the Canadian Journal of Plant Science where they were trying to drill down into some trends on the prairies. And there's some things I've grouped into a green box because I think they're opportunities. And the big one is, the number of frost-free days is decreasing by about 3 weeks. So I think, to be an eternal optimist, I think that's a positive potentially. Frost-free period then obviously is also changed by about 3 weeks. And so our growing degree days coming up a little bit. The thing we were talking about before we went on air here live was snow cover duration is decreasing. And we're also getting a decrease in off-season precipitation, something I think we could all agree with and concur that's happened this past, thanks to El Nino or whatever it's been. And then here's some conventional thinking. I grew up on a farm just east of Lethbridge, so we were in a crop insurance zone. And I think crop insurance, to be honest, drove a lot of these planting decisions back in the day. Maybe they still do. But really the idea was planting was really governed by not any sort of biological systems thing or awareness to that, but more like, as long as we're in by May 10th, we're good to go. And so there was the year where we actually went out in February. It was, things as far as our prescriptive approach went, dictated we start planting. And this guy here on Twitter was like, "Oh, calm down, everybody. Way too early to seed." And then he quoted these preferred temperatures, and the preferred temperature is 20 degrees. And I wouldn't challenge that was the conventional thinking. I went back into some of my older papers where we reported when we were planting. And for the spring wheat components, we were in that 10 to 15 degree range. And by that, I mean what we're observing in the top 2 inches of the soil. And so that's kind of been the conventional thinking, either governed by crop insurance deadlines or, something like that, and less about the biological or the crop physiological implications. And then just, what we're doing with this concept of ultra early planting systems really lends itself to this framework of G by E by M, which is the genetics by the environment by management. And if you've ever been around breeding, you guys are in the seed business. So if you've ever hung around with breeders too much, you would have heard this term G by E, but quite often we never talk about it in terms of a full system of G by E by M, which is kind of a universally global accepted acronym. We used to call it ICM in Canada, Integrated Crop Management, and so on. But when I got involved with the Weed Initiative, I kind of brought this to Canada because that's kind of what everybody else is talking about. So we may as well get on the bus that way. But anyway, you would have sort of silos of G by E over here with the breeders and E by M type stuff going on with agronomists. And it's really important that we sort of bring that together as much as we can. It's not always possible, but it certainly is more than we often do. And so how does it fit within ultra early planting systems? Well, the genetics, I was convinced we needed special genetics, and I'll talk more about that later. And also, what are the implications across wheat classes, since we tend to have about 7 or 8 of them market classes of wheat on the prairies. And then the environment, it's the cold soils, but that you're planting into, but there's also all these other implications of the environment, the growing degree days, heat stress, trying to escape that, obviously, and so on. And then the management is just that agronomic piece, your precision ag, your equipment, everything feeds into that management component. So there you go, Katie. You now know all about G by E by M. And we've been aware, obviously, that it's kind of a new concept. So we've been making sure that, and particularly with Graham, we're getting him to publish the stuff, and we were actually invited to put our work into a special issue with the Agronomy Journal. That was an invited thing that sort of, I think, was a nice feather in the cap of the project itself. So we're not just, we're proving what we're doing, and it's getting peer review. And the other interesting thing about it is the Australians are doing something quite similar, because they're trying to mess around with different planting, because their things just aren't syncing well with the limited amount of water that they have too. So it's on the radar for them as well. Now, when we think about canola, especially, I think, and even wheat, we sort of have this idea of conventional thinking, well, the longer you can extend that growing season, excuse me, the higher the yield. So we have this linear relationship between growing season and yield. And Gustavo Slafer here, who I've come to know, quite a world famous physiologist, he's sort of challenging that with a recent paper last year, and saying, well, no, it's actually not the way it should be. What we should be doing is really focusing on a critical growth period and managing that. And really what happens outside that critical growth period is immaterial as far as yield attainment. And I would tend to agree with that based on what we're seeing in multiple projects. And the critical growth period is basically the time that you start with your stem elongation, and then it's 10 days post anthesis. So within that. And so think about that when you're thinking about managing a crop, and the real key thing outside of that is just making sure you've got all your practices dialed in so that you're optimizing this source strength here that occurs there, because that is what's going to influence the sink strength. And in this case, the sink obviously is the seeds and your yield. So pretty important stuff. And the last thing about the critical growth period, and explaining why, for example, Manitoba is a good example. You'll generally get higher yield out of winter wheat than spring wheat. So why is that? Well, there's a couple of reasons for it. One, generally is that if you look at the arrow here, this is the critical growth period of winter wheat. And notice how in this schematic here, it's actually longer than the one that you have for spring wheat. And the other problem with spring wheat is where it's located, right? The critical growth period is deep into July, where you get those high temperatures of anything at 31 degrees and above is going to kill florets basically and kill your seed production. So it's something you want to be escaping. And winter wheat does that. And that's why, you know, we talk about what's possible for yield up here. The reason you get those gangbuster yields down in South America with their wheats, it's because they have this environment where they can stretch out the critical growth period. So they get the radiation, but they don't get those high temperatures. And so they enjoy a much longer critical growth period than what you see up here in this example here. And same with winter wheat, you know, in the Northern Hemisphere. So that's kind of the background of that and how it sort of feeds into what we were thinking or an explanation of why this has been successful. And really, yeah, that's what we wanted to do. It was like I was driving down to a meeting in Montana, and there are farmers out there that were already scratching the ground. They weren't seeding, but they were prepping. And I was like, well, why can't we be in the ground now? And that's kind of what got it all going. But I was convinced that we would need special genetics to do that because of the abiotic stress of cold soil. So Rob gave us 3 lines that we compared to Stettler here. And basically, this is just a prescriptive practice of as soon as you read, you know, 0 degrees, 2, 4, 6, 8, 10, as soon as you read that, what we call soil temperature trigger in the top 2 inches of soil, you go plant if field conditions allow. And surprisingly, more often than not, the field conditions do allow us to do that. Now, obviously, that's not always possible in every field and every year, but it's actually facilitates itself more often than I thought. So we started 0 and all the way to 10, and keep in mind that conventional thinking of 17, 15, and so on degrees. So we weren't even at conventional really with 10 degrees. And yeah, this is, what the hell, where are we here? Yeah, this is us going in. This is an example of in March. So these guys would have been with their soil temperature here, minus 0.8. Okay, we're not going yet. And then they read 1.8. They're good to go. And you can see these are conservative pack openers. So it is kind of a real world type simulation on a heavy frame, multiple ranks, and really nice conditions. And then the next question with this project then is like, okay, that's great, but I mean, what the hell happens after? Like you go and plant it in February or March, and we're like, yeah, you know, look at some of the examples here. We had 36 days here when we planted on February 16th. 36 days where it was below 0 after that, as cold as minus 10. We even had frost events. The coldest I've ever seen actually in May, where it was like minus 11 or something. But it didn't hurt. It didn't hurt the plant. And so think of that critical growth period and the stress occurring outside of it. And what the impact was, well, it really wasn't much of an impact. So to Gustavo's credit there, I think what we're seeing is kind of what he was trying to explain there. And then of course, great, Brian. So, but what about yield? And that's a fair point. And we had a bit of a reduction with yield right at the earliest, so at that 0. And what happened there, I think, is we had 1 year at Lethbridge where it was still a bit tight and frozen, and we pulled up some aggregates because that conservative pack opener is pretty aggressive. But generally, what we're seeing now is anything over 0 is giving us good yield. And so you could see it here, you know, good yield, and then it starts to fall off. As soon as we get past that sweet spot of like 2 degrees to 6 degrees, anything after that, you're starting to lose yield. So at a minimum, what we're saying with this is if you're going in ultra early, it's protecting yield and probably giving you better yield stability. So consistent yield from year to year, field to field kind of thing. And this is the kind of the stability we're talking about. Maybe I'll focus on this red box here. So this is just simple yield up on this y-axis here. And this is the variation of that treatment. So obviously Stettler isn't as high yielding as these rank genotypes that Rob gave us. But the story is the same anyway. Like if you think about that conventional planting at 10 degrees, it was the lowest and most unstable treatment we had in our project. Whereas anything in 2 to 6 for the most part was giving us not just high, but very, very stable yields. And that was the first publication. So at that point, we kind of got our proof of concept dialed in. And then running at the same time was, okay, now we need to start weaving in those components of more management and coming up with more of a systems idea here, comparing the age-old coffee shop debate of seeding rates of 200 versus 400. Depth is always a question. In this case, 1 versus 2. And then I just dialed back the temperatures a bit just to make everything fit nicely in that. And that's where we had that. The earliest at the time was February 16th, and that's the date right there. And you can see, I mean, the conditions to plant are really good. And we've gone earlier than that now. So, and basically here's just another more to the point where anything beyond that first 1 or 2 seeding intervals were causing a yield drag. And if you're also cheating your seeding rate at the same time, like if you look at this right here, for example, if you're here because you cheated your seeding rate and planted later, think about, you could have actually been up here with your yield instead, because you also facilitated that higher yield with that higher seeding rate. And it's true, there's often times where we can't see a, for example, yield advantage over some of these higher seeding rates versus, 250. But the intangibles and what you get for yield stability year in, year out have got to be worth something to you. So, and then this is just a little bit more of an explanation of why we're seeing results that we are. It's because if you get to the summer solstice, where you have the maximum radiation that you can capture, well, you need a photosynthetic machine that's able to absorb that. And you get that with these earlier seedings. Whereas if you waited to more normal, you just never could catch up. And it's even worse, again, this black dash here of a lower seeding rate as well. So you sort of compound the problem when you start thinking about multiple practices. So back to the critical growth period then, like, so what happened on the prairies then? And we were doing this as far north as Dawson Creek, BC, and well into Saskatchewan as well. This isn't just a Lethbridge thing, but Graham and I really couldn't make a case that we're, lengthening the critical growth period, but what we've definitely done is shift it out of July. And that to me is the key thing behind the success of it and the higher and more stable yields. Whereas with conventional planting, you're still well inside July. Like last year and the year before, I think last year particularly, we had like significantly higher growing degree days. And that's because of some of those wicked temperatures in July. And think of like 31 degrees is sort of that magic number of it. And that and anything over leads to floret abortion, and your seed set is now taking a hit because of it. And so really this just kind of summarized what I've covered. The one thing here is that we didn't need special genetics. Stettler, and I think just by default of, these, our breeding programs being in the northern latitudes, by default, they're breeding varieties with pretty good, resistant to the abiotic stress of cold soil. So Stettler did just fine. We didn't need special genetics. And then when you put sort of a cost to this, so I had Graham work up some just simple economics using Lethbridge as an example, in that, think about it, it was May 10th is the cutoff. If you waited till May 1st, cheated your seeding rate, instead of going ultra early with a high seeding rate, you were in the loss range of about $200 a hectare compared to what you could have had. So you are leaving pretty significant dollars on the table. And then that was the second publication. And then this is sort of where Graham took and ran with the concept, stacking in some additional things. And the one first step that he did is he looked at all the other wheat classes except durum and noted that basically that we're seeing the same thing, and there's no risk with any of the wheat classes out there, with any of the conventional genetics that are out there as registered varieties. So real good news that way is there's nothing needed on the farm in the way of special equipment or genetics to adopt this type of a system. And then the other cool thing that's really challenging here is, okay, obviously, Brian, in February, I'm not going to go out and spray pre-seed glyphosate or whatever, some kind of burn down, because there's nothing to kill. And so we have to do a rethink on that. And so Graham, who incidentally works for New Farm anyway, this was right in his wheelhouse. So we looked at soil residual herbicides like pyroxasulfone and the like, something that you would apply in fall. So if you plant a little bit ahead, you put down your soil residual herbicide in the fall, and you're good to go. And we've done a pile of research on that in winter wheat as well, and it's very effective. And that's exactly what he found as well. We didn't have any tolerance issues with that. So another good, good strategy that's replaced spring burn down, and it's a good weed management tool for this type of a seeding system. And so the next step for us was, what happens with durum? Because durum's different. It's not a hexaploid weed, it's a tetraploid weed, so it could be different. And we kind of heard two different camps on that. One saying seeding, because it's more prone to sprouting, would be a bad idea. Others saying, it'd be a good idea. And so we were lucky to get Sask Wheat to fund this project. And it turns out that ended up being one of our earliest ever, February 9th in Lethbridge, when we hit 0. So we hit our prescriptive of 0 degrees to start planting. And, you can see it again, like really nice conditions in February 9th. So, what's happening in terms of results? Well, similar type thing, right? Is like, you have this sweet spot of say 2 degrees, and everything after that is sort of causing a yield drag. And so I think we've got a pretty solid case here. So we're well beyond proof of concept here, for sure. And then so one question that came from a farmer when we had a tour of this in Lethbridge, of course, is like, okay, great, Brian, but why don't I just do it in the fall then? And I'd been a big proponent of winter wheat at the time, and I was like, well, why don't you just plant winter wheat? But finally I relented, and we did put in a dormant seeded treatment. And so the idea there then is like, the prescriptive practice for that would be is you wait in the fall until things cool down to 2 degrees or colder. Otherwise, that seed has a pretty high probability of sprouting. And it turned out at the time we had a farmer near just north of Brooks, Rolling Hills area, Kent Sarita, who was gung-ho to try it. And they were going to do it in October, and his crop consultant phoned me, and Promax Agronomy, and I talked them out of it and asked them to wait, follow his prescription, and they did. And I think it turned out all right for them. This is the danger, though, of doing it, though. When we went on that February 9th date to start our actual ultra early treatments, we noticed that some of the dormant seeds have actually popped a bit. And when I saw that, I was like, oh shit, that's going to be completely written off. But it wasn't. So what is it in terms of a relative yield when you do succeed with that? Well, it's basically the same as waiting until 10 degrees. So you get this sort of, I think, yield response similar to a conventional planting date is kind of what we're seeing there. And again, same thing. I mean, here we are with the February 9th planted, where we got conditions not a whole lot different than we have right now outside. And the seedlings were even up in April, and we got a late snowstorm, but they did just fine. And think about that critical growth period again, nowhere near the critical growth period. So that type of beating it up over in here really doesn't matter much. So if you get hail in here, grazing, whatever, that's why there really isn't much of an effect on your yield, because you haven't altered this unless you've screwed up this source right here. So keep that in mind. And so what are growers doing? Had several early adopters that have taken this and had really good success with it. And it was a typical phone call of like, hey, Brian, you told me 2 degrees, I'm seeing 2 degrees, but nobody's turning a wheel anywhere near my community. Should I do it? And I was like, well, if you're good to go, go. And it turned out to be a year where we had that frost event where they planted and they're like, well, shit, this looks pretty good. And then, we get that frost. So I'm getting a call again. Hey man, there's a blizzard out. And I thought I would be taken out and, strung up in the village square because of this idea, but it turned out just fine. And some of them are saying, this is the best wheat crop I've ever had. This is one, Matthew Gold out of Central Alberta. Those guys have been real proponents of it after trying it now several years in a row. And you can see, I mean, there's like snow in the tree line and they're like giving her and planting, and it's turned out really well for them. Another fellow out by Weyburn gave it a go and turned out really good for them. So what I think about, just to add to it, like some of the other intangible benefits you're getting out of it are similar to what you would see perhaps in sort of a winter wheat type system, because you're now breaking your sync with regular life cycle implications in relation to diseases and pests of spring wheat. So that's one thing that's an advantage. You're kind of spreading your workload similar to what you would with winter wheat, because you're spreading out that seeding window. You're harvesting earlier. You're getting higher to equal yields. You're getting higher yield stability. It's more profitable potentially, and at a minimum, you're protecting yield. And so, it's turned out to be a really positive win for a lot of growers. And since we're in Manitoba virtually anyway, Steve Shirtliff sent me this book, probably to remind me that it's really not such an original thought. So maybe he's right. But anyway, if you haven't come across this book, The Wheat King, it's kind of interesting. AJ Cotton in Manitoba. And look at the seeding dates. 1889, he was in there in March 25th, and they didn't know any better. They were just like, okay, if we're good to go, let's go, right? There was no crop insurance, paradigm. There was no cultural thing that would say don't do it, right? So they're just doing when they think they can do it. And so what's doable in March 25th in 1889 is probably even more doable now. So I'll just leave that with a final thought and thank my funders, and Graham and Dr. Zizi Wang, who's a research associate, helped me with some of these slides, and thanks for your attention.
Okay, thank you very much, Brian. That was great presentation, and I'm sure we'll have a few questions at the end. I know I definitely do. Asked Brian if you could just share with the group your answer there. Was there data on what temperature the wheat seed germinated at?
No, we didn't really dig up any to assess that, because previous research has shown that those seeds could sprout in temperatures as low as 3 degrees. That's why with the dormant seeding, we're telling farmers that if you actually want to risk that, you would have to wait until those soils cool down to at least 2 degrees in the fall, preferably more. And just to comment on the dormant thing, like it is a bit binary, like in terms of when it works, it'll work really well and you'll get comparable yields to conventional. But we've also had years in Swift, and I think this past year in Lethbridge, where it's been a total write-off. So there's a big time risk and reward. Whereas with the ultra early prescriptive of soil temperature triggers, you wouldn't experience that. And then there, you'd mentioned the thing about frost seeding in Ontario. Does it apply to Manitoba? You know, Manitoba might be kind of in between some of those locations, and frost seeding is different because they're going on frozen ground with disc openers once things have frozen up in the fall, right? So they are doing a real frost seeding. So it's along the lines of dormant seeding. And Bill Dean was the one that did that research, and they had pretty good results, actually.
Okay. A second question for you, Brian, was the wheat seed in your experiment treated or bared for this study? Was vigor testing of the seed a factor noticed between seed lots or varieties?
Yeah, so good question. And we did a bunch of research on this years ago. And I was totally blown away. We were using winter wheat as the plant type, and using a dual fungicide insecticide. And I know there's all this controversy with neonics and all that nonsense, but used as a seed treatment, it's safe, it's effective. There's minimal effects to non-target species. And the thing that it does for plants, particularly wheat, is it changes the metabolic pathway such that they become more resistant to abiotic stress. So if someone asked me in dry, sandy soils in the Turks and Caicos, would I use a seed treatment? There's years where I'd say, what for the biotic side, but the abiotic side, I'd be using it all the time. That's why we didn't even question it here. We just went with it because it's for sure facilitating those plants getting through that abiotic stress. Was there another question? I rambled on and forgot the next part.
I think that answers that question fairly well. If not, I think it was Laird that asked it, so he could speak up. But we have one more from Dorian Oliver. She asks, Brian, have you talked to any crop insurance about reseeding benefits if you were seeding that early?
Yeah, that's a good question. We haven't talked to crop insurance about if there are implications, negative implications from going that early. I don't know why you would, or why there would be, when the data around it is so solid. And we've got 40 plus site years, which is, you know, it's like a generation of farming. Like it's very solid that way. And again, think back to your critical growth period thing. If you want to think about risk, a lot of guys would say in a dry year, forget it, man. I'm going to wait it out until almost June for when the rains come. And now that entire growth period is in July. So the risk to me there, if you want to think like an actuariist and an insurance policy person, that's huge compared to the other way around. So, but it's a good point, and I should probably loop them in to just get some, you know, feedback on that.
Okay. I don't see too many more questions rolling in at this time. So I think we'll probably stop at that. I'm probably going to stop the recording at this point, and we'll move on to the draw. So just once again, thank you so much to Sherilyn and Brian for joining us today. We really appreciate your time.